Good morning, all of you. In today's class, we will learn principle of reversibility of light. What is that? Principle of reversibility of light. Principle of reversibility of light. So let me draw first diagram so that you will understand. So this is a interface now. You are having two mediums. Let us suppose this is medium 1, or you can keep it as a medium A also, medium A, and this one I am taking as a rarer medium having refractive index mu A, and this one I am taking with some dots so that I can say that it is a denser medium. What type of medium is this? Denser medium. What is this? Denser medium. And this is called medium B. Medium B. And it is having refractive index mu B. Now, when light ray we have incident from rarer medium to denser medium, what happens? This is a normal. And now it will bend towards the normal. This light ray will bend towards the normal. So here it is N normal, NM is the normal. This is angle of incidence. So I am giving, this one is angle of incidence, this one is angle of refraction. So here it is X, this one is Y, and this one is Z. So light ray will travel like this. Okay, this is the light ray direction. And now let's take mirror, which is placed in such a way that the angle of incidence is 90 degree here. Okay, this angle is 90 degree. So then this ray will reverse back in the same direction. Can you see? This ray will reverse in the same direction back. Right? So, what is the principle of reversibility? First of all, see here. If light ray if light ray travels from X to Z, see here, X to Z, from X to Z along a certain path, it will follow exactly the same path. It will follow exactly the same path, exactly the same path, while traveling from Z to X. That is, path of light is reversible. Yes or not? So going X, Y, Z and coming back Z, Y, X in the same path. That is what reversible path of light is. Is that clear? Understood? Okay. So let's move ahead. Now, see here what I am doing. So this is, can I write like this from diagram? From diagram, can I write like this? Mu A sine of angle X, Y, Z. है ना? Mu A into sine of angle X, Y, N is equal to mu B sine of angle M, Y, Z. Therefore, if I want mu A by mu B, it is equal to sine of angle M, Y, Z divided by sine of angle X, Y, Z. Call this equation number 1. This is from X to Z, while traveling from X to Z. Is that clear? So I am getting I will modify this equation number 1 and I will give again. So can I write like this? Mu A B, है ना? Mu A B is equal to sine of angle M Y Z divided by sine of angle X Y Z. X Y N आना चाहिए ना? Yes, yes, yes. Here it should be N, not Z. Okay. X Y N. Here also X Y N. Keep it in mind. Okay. Make it here N. So X Y N, and here also it is X Y N. We got habit of X Y Z, no? Yes or not? That's why X Y Z is coming. But actually, what X Y N is angle of incidence, and M Y Z is angle of refraction. Okay. So shall we keep now here as equation number 1? Yes, this is your equation number 1. Okay, this is our mu AB. Next now. Now from next you see from Z to X. Z to X. What you will get? Mu B sine of angle M Y Z. Yes, right? From Z to X, what you are getting? Mu B sine of angle M Y Z is equal to mu A into sine of angle X Y N. x by n. Okay, x by n. So therefore here you are getting mu b by mu a is equal to sine of angle x y n divided by sine of angle m y z. Yes, and therefore can I write like this? Mu b a is equal to this one, right? Wait. So I can write like this: mu b a is equal to sine of angle x y n. Hmm? x y n से z आ रहा है x y n divided by sine of angle m y z m y z. Now I can keep this equation as a equation number 2. This is my equation number 2. So now see, from equation 1 and 2, from equation 1 and 2, what I am getting, see once mu a b I got sine this by this, है ना? So can I write like this? Mu a b is equal to 1 by mu b a. Understand? Mu a b is equal to what? 1 by mu b a. This is what your principle of reversibility. Refractive index of one medium with respect to another is equal to 1 by refractive index of, that is, second medium with respect to first, we can say. Here you read like this: refractive index of first medium with respect to second is equal to refractive 1 by refractive index of second medium with respect to first. So this is reciprocal of one another. Okay, this is what your principle of reversibility. Please note down. First, note down this. Okay, this one. Okay, next. So let's move ahead. Next topic is optical path. What is next topic is optical path. I am denoting with X. With what I am denoting? I am denoting it with a X. Optical path. What is this optical path? So for that, let me explain first. So suppose now this is one medium. This is a medium. So like this medium. And now light ray travels from this medium like this. Now this is how much distance it has traveled from this A point to this B point. Light has traveled this much distance. Let us suppose this distance is D. How much is this distance? Let us suppose this distance is D. From A to B. And now we have taken vacuum. This is down I am taking. There are no dot particles. So let us suppose this is a vacuum now, which I have indicated with yellow square we can say. So here now this is a light ray which is passing. This is complete vacuum. So this is vacuum. And now from this also the light ray is traveling. So now let us suppose this point is A dash and this point is B dash. And this distance light has traveled in a vacuum. A dash B dash is distance traveled by light in a vacuum. AB is the distance traveled by light in a particular medium. So what is this optical path and what is geometrical path first of all? Now this d distance it has traveled, no? This d distance. Suppose this it has traveled in 2 seconds. Okay. How much time it has taken? 2 seconds. And this distance also how much? 2 seconds. So now the distance traveled by light ray, distance traveled by a light ray in a vacuum in the same time interval of that of medium. Okay, this distance is called your optical path. One more time listen, it is very simple. Suppose now in a medium it has traveled a d distance in 2 seconds. Okay, in a medium, suppose glass or something you take let us suppose glass medium. In the glass medium it has traveled the distance d in a 2 seconds. How many seconds? 2 seconds. Now how much distance it will travel in the vacuum in the 2 second, that distance is called optical path. That's it. Understood? Okay, so let's move ahead now. Okay, right, so first I'm writing definition. So first AB is what? Here AB is called, AB is your geometrical path or real path we can say. In this optic language this is called real path or geometrical path. And this A dash B dash is called optical path. This is called optical path. Sir, I want a definition. Okay, I am giving here the definition of this optical path. So see here. What is the definition of this optical path? It is the distance traveled by light in a vacuum, or if suppose you want in terms of this real path or geometrical path. So the optical path to a given geometrical path to a given geometrical path in a given medium medium is defined as distance traveled by light distance traveled by light distance traveled by light in vacuum in vacuum in the same time in the same time in which it travels a given path length in that medium in which it travels given path length in that medium. Okay, so this AB and A dash B dash are definitely not equal. Keep it in mind. These two are not equal at all. Why? Why? Because velocity of light in this medium is V, and in this velocity of light is what? C. Now see here what I am writing now below. See now, A dash B dash is equal to X is equal to velocity of light in vacuum into time. है ना? So can I write like this? X is equal to Ct. Okay, call this equation number 1. Now I want AB. What I want? AB. See here. I want AB now. So therefore AB is equal to velocity, or you can write as I have written X here, so you can write D if you want, because we have denoted it with D. Okay, so AB is equal to D. AB is equal to D is equal to velocity of light in medium into time, into time, right or wrong? So can I write like this? D is equal to phi into T, because time is same in both cases. So let us suppose call this question number 2. Okay, sir, understood. This is D, I understood. How we got distance, that is AB, and this A dash B dash also I understood. X is equal to C. Okay. Now, as this is a what we can say medium, so it is having, let us suppose, refractive index of mu, and vacuum mu is equal to what? 1. So not necessary. Medium of refractive index mu. Okay. So note down this all. Let's move ahead. Now, from equation 1 and 2. From equation, or first what I am doing, I am finding this time from equation 2 only. Okay. So from equation 2, d by phi is equal to t, right? Check it once. See, d by v is equal to t. Yes or not? Okay. So substituting in equation 1, substituting in equation 1. So what is equation 1? X is equal to c into t. At the place of this t, I am substituting x is equal to c into d by phi. So therefore, x is equal to c by v into d, and we know mu is equal to what? C by v. Yes, and therefore you are getting x is equal to mu into d. This is what your optical path. Okay, this is what your optical path is. X is equal to mu into d. Okay, next one, down below node point. Okay, below what I am doing, I am taking a node point. Optical path difference. Optical path difference. This optical path difference is denoted by delta x, and this is equal to what? A dash B dash minus AB. So A dash B dash is equal to what we got? That is x. That is your mu d. Yes or not? X is equal to what? Mu d only. Yes or not? Check it. This is A dash B dash. A dash B dash is x already. Yes. And x is equal to what? Mu into d. Minus this AB already we know how much it is d. And therefore delta x is equal to, if I am taking d common, then what I am getting? Mu minus 1 into this d. This is what your optical path difference. This is what optical path difference. Okay, note down this. Okay, next, let's move ahead. Now one more note point. One more note point. If in a given time t, if in a given time t, light has same optical path length, light has same optical path length, optical path length in different media, and if light travels distance d1, and if light travels a distance d1 in a medium of refractness mu2, in a medium of refractive index mu2 in time t, in same time t, then then mu1 d1 is equal to mu2 d2. You can create this formula your own also. Okay, once you know this previous thing whatever I have explained, then you can create this as. Okay, so yesterday I have sent you some problems. Nobody has sent me solution yet. I have given hints also, right? I have sent you hints. Please solve that problems. If you have doubt, please ask me. Okay, just don't neglect it simply. Understand, right? So note down this and please send me the solution of that reflection problems so that I can send you another assignment. Okay, so let's stop here for today. Bye.